Hello. Make sure please mute your mics before we start the today's session. Yeah, let's start today's session. Yeah, this is Sushmita. Good afternoon, good evening, everyone. Let's start today's session. Thank you for joining. Thank you for joining us for today's session on importance of sensors in enabling intelligent robot behavior. At ARTpark, we are committed to empower and upskill the startup ecosystem with knowledge, insights, and resources. We are delighted to welcome Dr. Ruth Josephine as our speaker today. Dr. Ruth serves as the lead technical liaison at ArtPark, spearheading the skilling initiative. In this role, she is dedicated to designing and delivering impactful training programs aimed at upskilling individuals across diverse technical domains. With a strong passion for bridging the gap between academia and industry, collaborating with experts to create a dynamic and relevant learning experience. Dr. Ruth is a distinguished professional with extensive experience in instrumentation and control. She served as an Inspired Faculty Fellow in Indian Institute of Science, Bengaluru, for 5 years. During this tenure, she led an innovative 8-month project titled Open Science Stack with Automated Labs, aimed at democratizing research access for researchers and budding students. Prior to her role at ISC, she was a faculty member at NIT Trichy for over a year, contributing significantly to the academic and research growth of the institution. Dr. Ruth completed her doctoral studies at NIT Trichy in 2015 with a research focus on shared sensing and actuation by shape memory alloy wires for haptic control robotic applications. Before we begin, here is a quick agenda for today's session. First one, Dr. Ruth will share her insights and strategies for next 35 minutes. Please note down. Following that, we will have a live Q&A session where the main discussions and interactions will take place, and you will have an opportunity to ask your questions directly. The webinar will conclude with key takeaways, closing remarks, and plenty of ideas for those looking to get involved and restart their careers in exciting world of robotics. So please note that we have a hard stop at 7:15 p.m. today. If you are unable to ask any questions from your side, please feel free to write your questions in the chat box beforehand. You are encouraged to drop your questions in the chat box throughout the sessions. Please feel free to do so. And also, we are trying to address all your questions as many as possible in the Q&A session. Please ensure to post your questions in advance. Okay, let's welcome Dr. Ruth to the virtual stage to explore the learning of the robotics world. Dr. Ruth, over to you.
Hi, Shushmita. Thank you so much for the very kind introduction. And also, this was a very, this warm welcoming. And yeah, let me share my screen. And
Dr. Ruth, please.
Yeah, am I audible?
Yes, Ruth, you are audible. No issue.
Hi.
Yes, you are audible.
Okay, thank you. Yes, thank you, Shushmita, for the very kind and that's a very elaborated introduction. And Yes, it's great to be a part of this Art Talks, which is where we mainly aim on
Recording in progress.
insights to innovation. And yeah, I'm a little bit nervous, and also I'm like super excited because I'm doing this for the, as a part of the team, and also, to do this, it's a very great opportunity. And yes, to go beyond this. So this is the first. So we thought that what type of topic we should start with, and thought this would be like kind of energetic and more welcoming, and a kind of, it might inspire people. So that's what we started with this. But continually we'll have some kind of episodes to give you a closure of how to build the robot selecting, and then you at least you end up with small kind of innovation in robotics field. Okay. So yes, so this topic would be of importance of sensors in enabling the intelligent robot behavior, right? So as humans, just as humans, you think we have this kind of sensories like seeing, hearing, tasting, smelling. So these are the five sensors with which we are, uh, living in this world. Without these sensors, it would be really hard and difficult to live a life, right? So that is where robots, or if the robots, to bring a machine to a robot form, we need sensors. Sensors that can be eyes and ears for the robot, for the machine, to know about their whereabouts, to perceive what is the environment they are in. That would help the robot, to help the machine to become a robot. And not only getting the it's beyond simply collecting the data of sensors. You have to, after collecting the data, you have to analyze the data, and then uh, do some kind of analyzing and processing the data to make it an useful information to execute a task. That is where it's truly distinguish a machine from a robot. Okay, getting inside to the topic, foundation of intelligent behavior. First is like how to how and when you can call a robot to be an intelligent. Okay, so this is the three key aspects that will that will help you to call, or that should be there, the key parameters to call a machine to be a robot. One is the anatomy. So anatomy is something a robot or a machine. Okay, let's call it as a machine, because without sensors, it's just a machine, right? So yeah, machine without any sensor, it has to know what it is, where it is, and what it is. So in order to know whether the machine is a kind of a ground vehicle or an aerial vehicle, or is it a manipulator, no, anatomy is something like the human anatomy, what it consists of inside the box. No? And the second one is that when you want to call it as an intelligent, it should have the ability to adapt to the environment. First, it has to perceive what is, where it is, and then whether there's an obstacle, then it has to take a different path, take a bend, or slow down the velocity, slow down the speed, or make a dead stop. So that's the second point. And the third is that make informed decisions. So there is already a program, as I said, there is a sixth sense for human, and for this robots, we can incorporate the sixth sense by using the controllers. So as and when it gets the sensor's raw data, it has to be processed, and it has to make as an useful information. So with this information, it has to execute the task. So that task, it has to be given to the actuator, right? So then this is what, when a machine does all these things, all these three things, when it can able to know what it is, all these three things, then it is called intelligent robots. So in order to make an intelligent robots, we need sensors, right? So what does this functionality of the sensors does in robots? So first and foremost is, it has to provide sensory input. It has to know its own state, and also it has to know where it is in geographical position, and also it has to know what it is going to do. what type of robot and what is its application, right? And the second thing is enabling the environmental perception. It is to know where the objects is, where is the obstacle, if it is it a dynamic or a static environment, whether the obstacles are moving, if it is moving, at what velocity it is moving, and also if at what velocity this is moving towards the robot or it is moving away from the robot. These are the information that sensor should give to the machine in order to make it as a robot. Third one is self awareness, allowing the robot itself has to know in what pose or position, orientation, and its internal state variables. What is the current state variables that they are working on it, that it is moving at that current time instant. So this is the main things that whenever a sensor has to be, even if it is one singular small sensor you're putting, then it has to give all this data to the machine in order to make it as a robot. And the three key concepts of intelligent behavior or the building blocks of intelligence is perception. Perception is gathering information from the environment. So the gathering of information which is done by the sensors. So this sensors, to mention the sensor can be one single sensor or it can be a multiple sensor, multiple of different sensors or multiple of even same sensors. Next is the cognition. Cognition is understanding and interpreting the collected raw data. Okay, and the third one is action, executing the task. So here you can see there's a simulation of conveyor belts where it is picking and doing some, it is filling the carton box, and once it moves, it moves. So now let me just break down this process into three. One is perception. At what speed the box is coming towards the manipulator is one thing, and the cognition is, okay, the box has arrived to the designated location. Now I have to do my job. So the information is getting flowed down to the actuator motor such that it goes to the appropriate position. The action is how it is going to place it, and it has to come up after the execution of the task. So this is the step or the process of operation that a robot has to do when it comes to intelligence. And all these things has to be done with its, at least semi-autonomously. So that is where intelligent behavior, without any human intervention, human knowledge can be given at the first place, but then human intervention should not be there inside the flow of operation. Okay. So next is enabling perception with sensors. So that when it comes to sensors, it is giving the perspective of what environment it is, but there are different types of sensors that are available. And now will be in a confusion what sensor to select and where to start with. So here are I've just listed down randomly the different sensor that's there. And this is a very commonly used sensor or the known sensors. Okay, proximity sensors, which is it's a sensor which is connected with distance between the robot and the obstacle or the object or the targeted object that you are working on. So here, this can be used for applications like obstacle avoidance, navigation, and also even for pick and place. This can be even for, navigation purposes. And vision sensor. Vision sensor in where cameras are used. This is mainly for identification, recognition of what is the object is, what is the target object is, and helps in visual surveying. And then there's the range sensors. They are the LiDAR or the radar. So they work on, 3D mapping distances. So they'll help the robot to know in which environment it is, what is the obstacle, what is the height, depth of the obstacle, and what is the, even the obstacle's dimension to a certain limit they can able to know, and then they can divert their navigation. And then there's the force and the torque sensor. The force and the torque sensor are mainly used in grippers. Grippers are like, these sensors are mainly used for whether they have, touched the object, whether they have picked the object, and whether they are holding the object while moving from one point A to point B. So that is where these sensors are used. And position and orientation sensor, this is for self-localization for the robot in a given environment. It has to know where it is, right? The robot, it has to know where in that environment it is now, it's currently placed. So that is where here position and orientation, that also helps in navigation. So here you might be having a question. All these sensor works as eyes, right? Eyes for the humans. So here coming to the ultrasonic sensors that will help us to detect what is the obstacle. Okay, so there's an obstacle, but then it's not going to identify what is the obstacle is. So that is where camera gets into the place and it is going to identify this is the obstacle, and the distance is going to be given by ultrasonic sensors. So there has to be a combination of these sensors, combination between these sensors in order to execute a task. Yeah, select and the next step is selecting the right sensor. So there are many sensors when you are coming, when the, existing in the market. When you're coming up with an application and there is, then you figure out first, what is your input want to be? What is your data? What should be your sensing data? So that has to be in place. And then, you work around the cost, precision, range, stuff like that. So coming to this, there are no, when there is application, there is like broadly three categories I have defined. One is the navigation. Navigation is moving around, which can be used with the combination of ultrasonic, camera, LiDAR, okay? And then manipulation, which needs to have a encoder, might be in for the motor, and then for the touch sensing, for the when it is holding an object, it has to have a force or strain gauges. So that's where the torque sensors gets in. So, and then the vision part, when it is coming for industry, then you need to have different types of cameras which will help you to know the thermal cameras, which will help you to identify where is the placement of this product and stuffs like that. So here there is a key consideration, and there is always a trade-off between cost and performance. Okay, so when you are coming up with high cost and you feel that performance can be less, then you can choose sensor accordingly. Or if you need, with high cost and with high level of performance, then you have to choose sensors accordingly. For this example, to give you a kind of an idea of what I'm talking about, so I have listed, I've shown autonomous lawn mover. Okay, you should be knowing about that. The lawn mover it cuts and it keeps the grass in shape in that height, right? For this, to make it move, you need some kind of proximity sensors, right? And then to localize it, you need some kind of orientation localization sensors. And then if you need, you can have a camera, or else we can also hot code some of the stuffs where you don't want to replace with the camera. So for this, I have listed, if you want to make it in a low budget, but if you're not looking for and also if you want to have a longer time duration to do that, then you can use with bumpers, which is like a contact type of sensors. It's like a toggle switch. So when it hits some obstacle, say it can be a stone or something in that place, and then it goes with a dead stop stage. And then after that, it will go with the ultrasonic sensors input. And if it is less than the threshold, then, accordingly, then it goes. So I can discuss about this control strategy in the later slide. So then it is the next one is the ultrasonic sensor, which will help you to know what is the distance between the obstacle and the lawn mower, right? When it is very near, this is going to slow down the velocity and it has to take a turn on the other side, left or right. And also you can use with simple compass with GPS for your positioning and localization where is the lawn mower is. Fine. So when you are using, I said you can even to put it on the table, you can even design a robot with a single sensor. But in order to make it a little more efficient and also a little more robust, a little more accurate to understand about the environment, we can go up with some, multiple sensor, and how to incorporate all these sensor data together. That is called multi-sensor fusion, right? So in that thing, we have to, multi-sensor fusion, we have sensor compatibility. First thing is that sensor compatibility is the data rate. Say, for example, if you have a bumper, say that's just a toggle switch, that's not going to have even a data rate, right? It will have a very, 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 the intervals or the inputs that you get from the bumper will be of higher range when compared to the highly sophisticated sensors. So the data rates at which it receives data to process, that is the data rate. No, high when compared to that, LiDAR has a high frequency even when compared to ultrasonic. So we have different, same sensors will also have different rates, data rates at which it transfers the data. So when you're purchasing, you have to look after which data rate of transmission is getting done between the sensors that you are purchasing. And the next is the frame, sensor frame. So when I say, we'll take the lawnmower example. So I have a ultrasonic on the front side of the lawnmower. So it is now the frame is set to the front side. And if I have a camera on the left or the right side tilted, and then what happens is that it is not, the data that we collect from both the sensor are not the same, because it is collecting the data from different environment. Unless you have to tell that this is under that, the ultrasonic is in 0 degree, and yeah, and you have to mention that how much angle or how much deviation is deviated from the current angle, from the neutral coordinates. Okay, the third one is the mounting. So when you collect the sensor, the mounting has to be, it has to be rigid. In case, even if the mounting is not rigid, it might, come up with some kind of small vibration, and which will turn out to be a noise in your data. Okay, so here, so if you have a multiple sensor, then you need a powerful board in order to collect the data from different sensors and put it into it, right? So you need a powerful board or suitable boards for it. So here I've listed out to have Raspberry Pi, and then, NVIDIA's Intel RealSense. They have the capability to have this multi-sensor fusion, as in incorporating more sensors into the board. And also the memory requirement. So when you collect the data, that's going to flood the memory, right? So here, so there we also have to check with the storage data of each of the processing board. Next is the sensor fusion algorithm. So in the sensor fusion algorithm, it says how to synchronize the data. The synchronization has to be when I collect the data at kind of the sampling rate is 0.01 seconds. So it has to be synchronized with all the sensors so that all have the same timestamps and the interpolation, right? So then with data filtering, we have to apply appropriate filters for each and every sensors. And also we have fusion techniques, in which we have complementary fusion, and then Kalman filter, and then extended Kalman filter. So these are the different types of fusion techniques. So coming into the sensor fusion techniques, which is a part of the multi-sensor fusion. So I have mentioned, what is it? The autonomous lawn mower, in which, so here, if you want to go with the building low cost with a high, low cost, but with no performance can be managed, you can just, for a certain level, performance is fine. So then you can go with priority-based fusion. So with this, I can, I'll tell you how this works. So there I mentioned we have bumper, ultrasonic, and then GPS plus compass, right? So here, so first, what it has to do is it will give priority to the bumper first. And then if it gets hit by something, and then if it is not, if it's not working, and then what it happens is, if it is a yes, if it is bumped, if the bumper switch is on, it says there's an obstacle, right? So then it goes to the dead stop stage. So it's going to shut down the system. When it is no, it's not the switch is not on. And then what it goes is it will check for the ultrasonic data, which should be less than the threshold. So threshold is a value that we would have already given in the program. Say, for example, like, the distance between the obstacle and the robot. So say it is like, 30 centimeters or something like that. So if it is 30 centimeters, less than that, it is going to reduce the velocity, and it is again going to estimate the, determine the position, and then calculate the path and adjust the motor and get a turn. Okay. If it is not less than the threshold, it is not going to reduce the speed, and it is going to go to the, execute the motor command. Okay. That is the priority based fusion. That is, each sensor is going to be prioritized, and then it will run the logics. So this also contributes to the intelligence of the machine to make it a robot stage. And then is the complementary filter. So here we have two sensors. Okay, two sensors, as in this, in this algorithm, what it has is we have two sensors which complements each other. Okay, here, for example, if you have, gyroscope and a GPS, so the filter is going to take down the higher frequency noise from gyroscope, and it is going to filter the low frequency noise from GPS. So both is going to complement each other, and it is going to estimate the orientation and the position. Okay. So the next one is the Kalman filter, which is going to predict the robot stage using a motion model. And then what is a motion model? The motion model is going to describe the robot, what the robot is first, whether it is a wheeled robot, or whether it is, whether it's a manipulator, or is it going to be an aerial mode, drone, aerial vehicle. So that is going to state what it is. First, it will give the motion model will give the, identify the robot dynamics, and next is the it will tell you what type of robot and what are the constraints. Constraint as in what is the maximum velocity or what is the angular velocity that it can turn, so that it can help you to know this is the capability of the robot. And then is the, here what they do is, it will help you to predict the new sensor measurements, and continuously it will help you to refine by estimating by weighing the predictions and the measurements. Extended Kalman filter is mainly for the non-linear systems, which will help you to first linearize, which we have to first linearize the current operating point, and then you apply the Kalman filter. So this is the extended Kalman filter. So now we look into the, it's just, to give you an idea how to build a motion model for the autonomous lawn mower using the low cost and also the high cost, both of the variants, I can say. So here, first I mentioned, that is like ultrasonic, for the low cost, it's bumper, ultrasonic, and GPS. So the angular velocity, it will be given by the, so angular velocity, it is given by the wheel encoder that's in the motor which is fitted to it. Okay, that will give the rotation, how much rotation the motor has rotated. Okay, and then is the change in the heading. This is how much angle it has to tilt. For this, we have to get the data again from the omega, which is again the input from the encoders. The change in the position, which is the delta, which will give you the orientation, which will be given by the compass, or in case it any other complementary sensors that we use, and the updated position. So this is the xy, theta, or xy the coordinates, and the theta is the orientation or the angle that we have applied. So next is this is the motion model that will help you to know what is the sensor that being used in this robot. Okay, so this is again the with yes, I think someone is scribbling. So with LiDAR and GPS, this is a state vector which help you to know what is the robot's position and where it is heading. This can be this data will be got by GPS and IMU. So that's what I stated, which data or which got from which sensor, so that it will be useful. If you want, you can take it down, but then, yeah. Input vector, this is the VR is the right wheel velocity, which again we get from the wheel encoders. This is again the motion prediction equation, which will help you to predict what is the next step with the current situation, right? So this data are again got from IMU and wheel encoders, assuming the velocity to be constant for simplicity. Okay, so this is something out of the lane right now, but yeah, it would be useful for you people, because when yes, to give you an idea of how this can be incorporated into ROS environment. So this is the ROS control node, which is going to represent your robot, and in which we have these three functions or nodes that you have to do it in order to make the robot to work. So subscriber is something you receive information. So in order to have the subscriber, you have to do the subscription from the sensors. So subscriber is where you get the data from the sensors inside the machine. Okay, so it's getting inside. Only when you subscribe, you will get the data from you will get the flow of data from the sensor inside the machine. So this is again the publisher, which is going to publish the data to the motor according with respect to the data that they have got from the sensors. It is going to publish what is the command velocity, what is the angle of twist, at what rate, and what is the Q that is going to take up. Then this is a services as in it's going to execute a task, which would be again on the actuator side. Okay, so this is the different, this is also the syntax. Here we have seen, we can see the self-pumper subscriber is equal to self-create. So that's going to create a kind of syntax where you can see its bool function, whether it is on or off, or the bool status. Again, this is going to tell you what, whether, when it is on or off, this is going to tell whether it has hit an obstacle or not. Okay, then it is going to call back the function. So 10 is a number of Q that you can make it to wait. 10 inputs that it can wait in a queue to get it processed through. And here you can see twist. So this twist is a message that will be published, and the command velocity is it's a common notation for the robot to take its speed and the movement. And here it's the emergency stop. This thing I have done with respect to the example. Okay, so that is what. Otherwise, it can also move right to left, so that it can navigate the lawn mower on the sides. So this is a session that for the today, but then I've got some interesting questions which I thought I could answer them. And most of all, so most of the questions out of many, it was like they are from a different background and they want to know about robotics. They don't have any idea where to start with and stuff like that. So I thought that we should start something from basics, or not basics, to get to know what has to be done when a fresher gets into the field. Okay, so anyways, I can take up some good, interesting questions. So this question is, okay, let me start with this. How do you handle uncertainties in the sensor measurement that might affect the intelligent robotic behavior, which otherwise compromise the intelligence data? So when you are, this is something like gathered intelligence, gathered intelligence as in the gathered data on a previous node, but not right away, right? So there is always, you have collected a data on the same perspective, on the same environment, and then you don't know how far you are this might go. The uncertainties in the new sensor is going to affect the intelligent behavior. So this can be, it can be reduced to by using this data filtering. And also this data filtering can be like averaging the datas, and taking out the outliers. So this will help you to a certain extent. And also when you call there's uncertainties in the sensor, we can also go with using different sensors of different different sensors that which does this, gives you the same data, or different multiple sensors of the same sensors. Okay, so multiple sensors of same type or multiple sensors of different type. Say for example, I can use the same ultrasonic sensors on 3 sides or 4 sides of the instrument, or different same ultrasonic sensors I can put at 4 places, or see or you can put in the same place one above the other and get the data, and you can know somehow to certain extent we can handle the uncertainties by that way. And next to start with is, for communicating dependent robotic functions as an internal publisher-subscriber architecture, how can we innovate such a process to receive input-output data in the real world without using any such architecture? I think publisher-subscriber is what you meant, if I don't take it on the wrong. But without publisher-subscriber, it's I'm not sure about that. But then, for example, there's also called a shared memory, but I've not used that. It's like a shared memory is something like a whiteboard where your team people can write down what is happening and update it. But sometimes you will end up with losing the data, who has written and who has erased in the board. So that is how it might end up. I think publisher subscriber is the best way, and it also has and I feel that's the only way that we can do it. Apart from that, because since now we are exposed to this ROS, operating system, I feel that's the best and the only way. Right? How is time synchronization and latency playing important role in haptics, and uh, involve multiple sensors, provide a brief of robotic sensing? Yes. So here we, think about synchronization and latency, which is going to be real. It is the main, right? Time is the vital in haptics, right? So that is one thing. And to answer the second questions, since robotics sensing involves multiple sensors, which of the combination of sensor help in haptics of domain? So right now it's currently normally they use force a torque sensor along with accelerometers. So that is the combination that you can use for haptics. Provide a brief of future of robotic sensing. Uh, right now, I came across this thing, and so I thought I could include this neurophobic sensors, which is done by this company called SynSense. They are using that for virtual reality for real-time monitoring. That also consumes very ultra low power processing and low latency. If you have any chance of knowing about this product, if you come across or if you're going to use it, just let me know, because this is something that I came across lately and I thought this would be an interesting, and then this question came up, so I thought I should highlight this. Which new navigation sensors are now introduced into indoor? Yes, so this is a kind of sensor that it came with Deka Wave. That's an ultra wide band sensor. They are very good in indoor sensing, and they have very it's a short range. Yes, of course it's indoor, and then they have like high bandwidth and data rate. Okay, so yes, is mechanical design good to learn how someone can be is currently in third year. So that's what. So I thought that we and my team were thinking that we can do kind of series of episodes. It's just an introduction for today, but then I would love to continue this course as an episodes for 6 together, and then everything we can wrap it up as a single uh, course under robotics, which where you can come up with building it, refining it, and somehow if it ends up in small innovation, I would be the happy person, and the team would be very happy to see this. So yes, and what will be the next? workshop. Yeah, soon we are trying a lot about, workshop. We are in, too many things we are running in our threads. And yes, definitely we'll be doing a workshop. And I would say like at the end of February or somewhere around, we'll be trying to do it. And to know more about it, you can follow us in LinkedIn and stuff like that. So yes, to answer the other questions, I think yes. It's better you start with what you know. If you have just a Arduino board and you have a motor on your own and you have a very small ultrasonic or infrared sensors, collect the data from the infrared sensors and just make the robot to run. That's a basic thing that you can do. You can start with, so that and later on you can put ultrasonic, or later on you can put some other sensors and you do sensor fusion. Start with sensor fusion with priority based technique, and then it eventually evolve. If you have the right passion and you have the right if you find really time and passion, that's enough to build your dream towards that. And yeah, thank you so much for this session. And do you have any questions? I'm very happy to answer it. Okay, there's in chat box. No, I can see it. You can come.
Thank you so much, Dr. Ruth. It was a very insightful presentation. I'm sure the audience will have a clear understanding after your sessions, and also they can take up the new courses as well, and also they can learn how sensor is very important in the real world. Thank you so much. Now,
Any
yeah, audience, if anyone has a question, please feel free to ask. You can talk to directly with Dr. Ruth.
Hello. Hello, Dr. Ruth. Very good evening.
yes.
Yeah,
Very good.
this is Dakshina Murthy.
Hello,
Hope you
sir.
are.
Yeah.
Yeah. Recently, I visited a casting industry in Coimbatore.
Okay.
They have one huge problem is they have a furnace. Furnace have optimal temperature, but they cannot switch off in proper time. Because of that, there is a lead time takes to switch off, and that costs their energy bill. Even if they run it for additional 10 minutes, they may end up giving energy cost of around 2000 rupees per hour.
Okay.
So they want to switch off it. Then they have a pyrometer, because that is 1500 degrees C molten metal. We cannot bring any normal temperature sensor or physical temperature sensor to measure the value. So they have a pyrometer. That pyrometer gives the data, but still the loop is not closed.
Okay.
In that case, how I can bring sensing part, or how I can bring any robotic support or a drone to do this sensing and switch off? What kind of things I can focus?
I mean, okay, to be frank, I'm more into robotics, but then this question is something like challenging. So this is okay. So what I understand from the question is, you need to switch off a switch, right? When the temperature goes beyond some
Yeah. Yes,
amount, and then in meanwhile, in meantime, it is causing some problem, right? So
even for example, to melt 1 ton of recycled iron, it takes 40 minutes. So in 40 minutes, it melted.
Okay.
But due to some reason, it's a manual process right now. Someone has to sense it, and then once it reaches the temperature, someone has to go and press the switch off button. So it takes 2 to 3 minutes or 5 minutes of time. So in that 5 minutes, what happened? The energy bill shoots up. 5 to 10 minutes. That cost, because nowadays industrial energy bill per unit 7 rupees to 10 rupees in the range.
I mean, I'm just trying to sort this out. But you said drone can you're asking me, can drone can switch off the
No,
thing?
not drone can switch off. Drone can go to the near to the furnace, certain
Okay.
range, so that it can capture by using my thermal imagery sensing part. It can capture it, process it, suddenly send a signal, because they might have more than one furnace in the that's the
Why a drone should do that? You can put a static camera over there and
no, that's the problem. The heavy heat around it, the physical camera may not work. That's why they are using pyrometer. Pyrometer means optical
yeah,
based temperature sensing.
okay.
That now they're using that kind of gun. The person from some 2 to 3 meter away shoot the gun, takes the data through optical means, then the data goes to the display. But from the display to the power control, there is no connection.
Okay.
That is right now. That is the
It
status.
has to be automized with some kind of actuators, but I'm not, I don't still know whether there's an actuator, say, for example, it's something with thermostat, right? That what we work in iron box, that's what hitting my head. Something of that on a bigger scale, we should look into it.
I tried
I can
also.
look into if you want, but that's not my, this is too much into industry.
No, no, even I'm not industrial person. Due to the curiosity, I went there. I saw, because he told no physical like thermostat and all
I
cannot
got
withstand. First time we may measure, but next time it will melt.
But my thinking is, why don't you hard code it if the time is going to be constant? If you say that for heating up it takes only this prescribed time, then you can when over a time, then you know what is the time taken to reach at that point. Why do you want to wait for that point to?
That's why I'm asking their data. But the good thing is they're collecting the data.
Okay, then.
Every 1 hour, there's a separate control panel. It's default by its collected data. So I'm asking them based on data. First, we can bring some inferences, and then we can devise a solution to that. That is the one thing. Other thing is in agriculture, people from Tamil Nadu Agriculture University, they are looking at a drone, whether it can measure the underground crop quantification. Suppose I have a 5 to 10 acres of carrot field, or what is that, potato field. It grows under the ground, under the some 10 centimeter or 20 centimeter below the ground surface. They want to know, if I have 5 acres of potato, what is the net quantity of potato? Without, so that the market price they can readjust, they can sell it. Right now, what happens? A salesperson comes to the field and he say, "This is your investment for last 6 months, so I will give 10% extra. You sell it to me." But sometimes the quantity might be more, sometimes the quantity might be less. They're asking whether engineers can bring solution this kind of things by using drone-based sensory part.
There are drones that they work on this agriculture, mainly on precision agriculture. But quantifying using a drone, it's
Quantifying underground crop quantity.
underground is fine, but then quantifying it, that can also be done if you train the cameras in it, that how it looks when it is in one group or two.
That's why I'm asking, is there some kind of good hyperspectral camera where it can take the imagery and do some kind of things?
Yeah, we can use the cameras, but on top of it, you need to train the data. That is
That
where
is okay. Once you collect the data, then the other part will be follows. First thing is how to get the data collection part by using good sensors. I don't know which sensor will be suitable.
Yeah.
That's what they're asking for me when I visited agriculture people.
Yeah. Okay.
Okay, thank you.
Any other questions? I can see that can be.
Hello, ma'am.
Yes. Yeah.
I'm Siri Tubaka. I work in an autonomous driving startup. So as part of my work, I was doing camera and lidar fusion, for which for the fusion, like I was using some calibration techniques using checkerboard and all. Like, and recently I encountered one problem, like we were keeping lidar and IMU together so that they are not in like in different places. For fusion, it would be easy. But I have a doubt, like what if they are placed in a with some distance, and how to get the transformation matrix between lidar and IMU, because we cannot use techniques like checkerboard and all
Yeah.
in these
So as
cases.
I mentioned, no, so that has to be, if you're using different sensors, the placement plays a very important role. If there's a difference in placement, you have to include it, in the equation somewhere, so that it is going to, neutralize it. It is going to bring both in the same scale. So that has to be done. Maybe you can share this problem with me. I can just check out. So what is that issue that you're seeing? And also just send me, how you have placed it. So
Yeah,
that will
sure.
give
Yeah,
idea about how it is. And that is that's yeah.
yeah. Thank you, ma'am.
Yeah, good evening, madam.
Yeah, please.
Yeah, this is Nagraj. So I'm building agriculture pesticide sprayer robot. Okay,
Yeah.
and we have developed a controller for two motor single controller. Okay,
Mhm.
so now you are asking for the sensor. Okay,
Mhm.
so should I have the sensor in the same board or should I make it in a separate board? Is it good?
I think it has to be in the same board, in order to have the good. If it is in different, why do you want different boards? I mean,
Because see, I'll tell you the always the controller board is temperature sensitive.
okay, fine. Okay,
Yeah.
got
So and why should I make the unnecessary sensitivity on the temperature? Make it a separate board for all the sensors and
yes.
integrate it here.
But
Okay.
what about the
So
data synchronization? No, the time, is it same? Is it all in the same? Does it have all with the same timestamps? Then it is fine. If it is not there, then you have to do some kind of, starting. If you have even different boards, you collect datas, and one starts to get collect from, like, even if it is like a millisecond difference, then it's going to make a at the end it is going to make some kind of big change, right? So where you have to, at the first only you have to, make both boards. If it is going to work, make sure they are going to publish, and the at the same time, at the same instant.
okay.
Yes, that is that you can do it even with open loop. You can just
Okay.
click and then just operate the motors and check whether how far if you have an encoders or something. I am not sure, but yeah, get the data. How is the timestamp? What is the variation in the time? And then I think that can be fixed.
Okay. So I have one more thing which I have seen very recently. I'm giving with an example. There is a person in Illinois University. So they have built a robot and they have removed the LiDAR. Okay, they are using only image sensor.
Okay.
Okay, they are using for agriculture purpose. Okay, so
Okay.
I'm giving you even further down the data. One is one robot which goes inside the corn fields. Okay, inside the corn fields, and it will show the sowing will happen before 2 months before it has going to be the removed. Okay,
Mm.
so what they have done is, so they found out, okay, the lidar is not good, so they are using image sensor. Okay, I don't know what is the image sensor what they are using. Again, they have built one more robot. Okay, so I have built two robots now. Okay, so why I'm giving this, I hear they have done this one. I'm not copying it, but by mistake I'm doing the same thing. Okay, the second robot, what I have done is, okay, this has got a single controller for two robots. In between there's a gap, and both the things will talk to each other. Okay, in that robot, okay, they have again used that is for the bigger robot. Again they use the image sensor. Imagine for the plantation area. Okay, in the plantation area, So they have checked, taken the image, even the bark size. Okay, when the vehicle going to move. Okay, not only the trees. Okay, the bark size, because when the bark size is there, so it will check the data from the image and it will go left and right. So it is not going to hit the tree itself. So, and even there they have removed the LiDAR. Okay, so they say okay, LiDAR is not required. Okay, so now my question was, when when they're using the image and they're taking the data, so what kind of image sensor they're using, and removing the LiDAR itself?
Okay. How? Sir, it's like, if it is my product, I would reveal this. But to my knowledge, I'm just thinking randomly that they
Yeah.
would already map the area, mapped. So while mapping it, they would have used all the LiDAR and stuffs like that. Okay. So now they have, coded everything, because it's not a dynamic environment might be. It's going to be a static environment. Okay. So the starting point of the robots is going to be the same. The 0, 0 point, they are going to maintain the same. Fine. So in that position for the robot, it's going to be blind. It is something like, say, for example, if there's a power outrage in our home, how we will know? It is known place, so I know I am not going to get hit by any things or obstacle. There won't be any obstacle. I know where my things are placed, and I can easily navigate if it is my own home, right? Because I've already known where I am. What is same way the robot can also, they would have already mapped it, and they would have known that is not the primary function of how to navigate it, rather than it's more of about health of the crops. So they have just put the camera to get that application done.
Okay. Anyway, I don't want to comment now. Okay, but my thing is, okay, I have sent a mail. They have not come back to me. Okay, that's a different thing. Okay.
Maybe you
So,
share the link with me. This seems to be an interesting thing.
yeah, I will send
Sir, in that,
details, and we can talk later. Maybe
excuse me, sir.
Yeah.
Excuse me, sir.
Yeah.
They might have used, there is a vision language model. So initially, while capturing, they use all the LiDAR. After that, they use vision language model. Then only they remove the LiDAR part, and then only image is enough.
Very sorry, I don't want to comment. Okay, so that's the reason I'm not commenting. It is no, they purely they have removed the LiDAR itself. Even this is the dynamic. Okay, it's not a static. So I don't want to now just comment on it. Okay, let's next session, if she is taking, by the time I'll give her a data with all the software also. It's open source. So let's talk in the next thing, because let's understand how they are done. Okay, I don't want to comment right now. Sorry, I don't feel bad.
Yeah, any other questions?
Okay. I don't think any question is there.
Yeah, we can share the PPT. I think it will be already available in the YouTube. Right?
YouTube, yeah. Okay. Sushmita?
Yes, sir. Yeah.
Yeah, now you can close the session by thanking the speaker and audience. Yeah.
Yeah. So if there is no more questions, so we can conclude today's session. So uh, I would like to extend my heartfelt thanks to our today's speaker, Dr. Ruth, for sharing her expertise and providing valuable insights on importance of sensors for robotics. I am confident our audience has taken away all the insights what she taught in today's session. So a big thank you to everyone who joined today's session, and also ARTtalks team of skilling as well as marketing team for ensuring a smooth execution of this session. Special thanks to our Art Park for the support in organizing this session. Thank you all. And also, if you have any more questions, you can free to email us via skilling@artpark.in. And also, you can contact our today's speaker, Dr. Ruth@artpark.in. So yeah, thank you all, and I have a happy weekend. Thank you so much.
Okay, thank you. Thank you very much, team. Good job.
Thank you, sir.
Thank you.